Hello CIS40A. In this video I'm going to go over week 1 objective tasks in the notes. You will find this module open on Canvas. It would say week 1 objectives and tasks. And here in this week we are going to cover characteristics of networks, different types of network topologies, the appliance inside the network, looking at media like cables and other form of media to be able to establish a network, and also network architecture and operating system. So for this week we are to read chapter 1, look over the notes and the videos, complete week 1 assignment, and we are going to complete lab 1-1 and 1-2. So right now I'm going to go over the notes for this week. You will be able to find it here. You can view it inside the page or you can download. And as I go through the notes, I will address some of the questions from the assignment. So in the first week, we are going to cover the basic network concept. And network is defined as 2 or more connected computer systems to be able to share resources, data, and applications. And by definition, you can see that for our system, we can be connecting as a peer to a peer, a computer to another computer, and that the second computer can be connected to a printer. You can also have it hierarchy where you would have a client-server environment. So here it shows the host as a system connecting to another host as another system. A host can be any appliances inside the network. It could be a computer, it could be a network device, it could be a switch, a router, a printer, etc. So in your assignment, for the first question, it asks you what is a network, and we can say that the network is 2 or more connected computers, and those computers can share resources such as data and applications, office machines, internet connections. It could be a combination of these elements. Now in the next section, this section talks about local area network, which is LAN, and then we will go into WAN and MAN. So a local area network is restricted by the geographic location. So in an organization, you will find that there might be a local area network for the business. It could be small or large. It's enclosed inside the office building. It could also represent a single department, a corporate office, or even a home office. And within the local area network, we might have a work group, which could be a group of devices that doesn't have any kind of rules for security. They're able to share resources on the work group, and without having a domain, which is a server, usually in a network environment that will default to a work group. So what you see below is it would be a client-server environment, not a work group, where you would have multiple servers, and those servers are connecting to a centralized appliance like a switch or a hub, and then the system would then be connected to a switch or a hub. The drawback about having a work group is that the work group doesn't allow you to be managed in a sense where you can't get one LAN connecting to another LAN to be able to share. You have to physically be connected to a work group in a local area network to be able to share resources like printer, files, etc. And work group tend to be smaller, and so when you're looking at a larger work group, that would slow down the network performance tremendously. So when we're saying small, we would want to say like 10 or 15 systems. That will probably be a very large work group. In comparison to what you see with a client server environment, you can have thousands of systems as clients connecting to the server side. So it's intended to be for a small scale. And when we say peer-to-peer, is that the computers that are connected to each other or under that work group, that could be equivalent in the roles. There's no higher system that's controlling the hierarchy. So when you are connecting at home using your wireless home router, you are in a peer-to-peer environment unless you have a server that are controlling the roles of the system and also the users on those systems. Now, peer-to-peer is lacking in the fact that it's not going to be manageable on the larger scale. So in the larger scale, you wouldn't want to use a peer-to-peer client-based systems. So to answer the questions for number 2, it asks you to define the local area network. And a local area network is restricted to the spanning of the location, the physical location of the building. It could also represent a single department like sales or finance. And the example for a local area network would be a business network. And in that network, you would have computers, printers, servers, mobile devices connecting to share resources. For 2B, we would define workgroup as a set of devices with no security association to one another. So in this context, we would simply mean that they are physically connecting in the same network segment, but there are no applicable security requirements across these systems. The example of this would be a department workgroups for a small business or even home networks. For 2C, we would define wide area network, and that would be WAN. So WANs usually need a router or a router port, and so beyond the router, that would be your service provider networks, and that would be considered wide area network. Before the router, within our network, that will be your local area network. So the router is really a gateway for your data to enter your network and leaving your network. WANs can utilize either private or public data transport media, such as phone lines. It could be using satellite, or it could be using different type of media to be able to connect. And a distributed WAN would have inter-networks, so you might have multiple networks. So in the case where we would have a corporate office, and that corporate office would then be connected to some of the branches. So you would then have a distributed WAN that would make up of a lot of different interconnected computers that are located in different locations. So you would often see that with an enterprise environment. And we would have the router to interconnect these networks together. So each of the network would have its own router, and that router would then be connecting across, whether to the service provider or directly on from one location to another. So you would find the information for WAN also included in the notes. And on page 3 here lists the common network components. We have workstation, that would be referring to the computing system for the employees, the users within the organization. And workstation tends to be a little bit more advanced or enhanced in the hardware, in that it would have regular use compared to your home system sometimes. And that can vary too. It doesn't have to be exactly like that. For the servers are computer systems that are provided services for different resources. We would have something like a file server. That is where we would store files, and the users or the system are be able to pull the files from this particular server. You might have a mail server. That would be your network post office, to be able to distribute, receive, and send mail. So it would handle email functions. Your print server, that would manage printers on the network. So if you have 100 printers, we can manage what's in queue. And we can even control down to the number of prints for the user. And print server doesn't always have to be a server operating system that's installed on this machine. You can use desktop operating system for that. And servers are always going to be on, and we wanted to make sure that they're configured to service other machines. So the IP address of the server stays the same. It doesn't get changed. Your web server is used to manage HTTP requests, and it would store the web content. It would have index pages that would load, so that way there would be a website. So web servers are usually connected to be able to give some kind of web presence for the organization, whether it would have an interactive with the user or not. Organization might have a fax server that would be named as a memo maker, and so we can digitize our fax and be able to send that out and receive fax. There also could be application server that would manage network applications that would be used for daily operations. There could also be telephone server or telephony server that would be for call routing, call center base, and usually customer service based call center. You would often see this. And then we would have proxy server, and that would handle the tasks in place of the machine on the network, particularly internet connection. And my analogy for this is proxy server is like traffic police. It would then direct some of the traffic to a certain area of the network. Here you should see a diagram where we would have secure room servers, and then we would connect the workstations, some of the hosts, to the servers, and these hosts here are in different departments, and they would be segmented so that way they can also be connected to obtain the resources from those servers. So in the client server networks, the advantage of this is we can manage the resources. We can apply some of the control in how the users access those resources. In the wide area network, as we mentioned before, that will be using ports, routers. It would span in the larger geographic areas. It could be across different cities, across multiple countries, and so on. So the internet itself would be considered WAN because it's connecting lots of different networks together. Internet service providers like Spectrum, Frontier, Cox, Charter, etc. And so that would be expanding in the term of internetwork. So give us internet. An internetwork, the host would use hardware addresses to communicate with their host, and the logical addresses would then communicate with the host on a different LAN. So this is why you would have public IP leaving your network. So the public IP would then be used in the wide area network, and the private IP, which is a different IP address, that would be inside the network, in the local area network. So when we represent the cloud like this, the internet, all of that is just encompasses WAN. And we would then interconnect with multiple networks in order to get from one location of our company to another location of our company that's different in the geographic location. So on page 5, you will find the definition for internet, intranet, and extranet. We already talked about internet, so for intranet, that will be a network that's used for sharing information, collaboration tool, operating system, and computing services for the organization. Some organizations use intranet for its partner, vendors, and employees that are working remotely sometimes would be able to obtain some resources with the intranet. The extranet, that will be a private network that allows partners and vendors and suppliers. So in some cases, extranet will be used for external users, external entity that will be connecting. And that would be located in the DMZ, which is demilitarized zone. And there would be authorized access and control in the access based on roles or rules. Typically, you would see a virtual private network set up for that to elevate the security landscape for the extranet. So you can take that information and put it down for number 3. It asks you to define intranet and extranet, the difference between those two. And for number 4, we already talked about the workstation. That would be the systems that is used by the end user in the daily operation of the business. For the business network, different type of servers, likely that they would have mail servers, file servers, print servers, web servers, fax server, application server, proxy, and telephony. And we didn't include domain name server or dynamic host control protocol systems to be able to distribute IP addresses. DNS is used to resolve IP to the domain name or fully qualified domain name. So here you just need to include 3 or 4 different types of server. For the next question, it asks you, identify 4 to 5 hosts in a small business network. And so a host could be a laptop, that is a system. It could be a tablet, it could be a workstation, it could be a server, it could be a point of sale system. And all of them would then use TCP/IP, which stands for Transmission Control Protocol and Internet Protocol. For number 7, you just need to search the internet to locate some information for network devices. So I will do one example and you will be able to you can use Google and you can look up a type of router. And let's try to use the wired router. So let's say that I wanted to use Cisco router. I will be able to find some Cisco router information. Here you would see that there are different types of router that's produced by Cisco. And so you would, from a small scale to a large scale. So let's say that I am a small business. So here is the Cisco for the small business. And as you can see, it looks a little bit different than the switch. On the router, you would usually have about a couple of the connections for the in and out traffic. So it's going to be able to route. The important part about when you're looking at these devices, that you want to look at the throughput for a specific service. So if I'm using this for virtual private network, is it going to be adequate for my users and my overall network? And so it has an integrated 4-port switch. That means that it would have some additional ports, so you can connect other switches or other appliances to it. We also wanted to look at how we can expand in the area of security and remote access, which is IPsec here, and VPN. And then the protocols that it supports. So it would then have DHCP, DDNS, and so on. And these protocol is tied to a certain service. So if you want a specific service, make sure that the protocol is indicated or is included in the specification. And then also the routing protocol, we'll touch on this later on, but the routing protocol is important because that can give you the performance. If it's using something that's older, like the version of the RIP, or if it's lacking a certain protocol that you're looking for a certain service and routing, that you want to pay attention to. Okay. Now, as you go through and take a look, all you need to do is include some information in the URL for each of these. A managed switch compared to an unmanaged switch. An unmanaged switch simply is just an appliance that we would connect the system together, and it acts almost like the repeater. It takes the data from one system that is connected to it and be able to switch that and send it forward to another system. There is no interface, no operating system like iOS for Cisco to be able to manage. With the managed switch, we're able to manage the resources on that switch, the features, we can control the ports, we can enable or disable a certain type of service that's tied to a certain protocol. So you will look up these information and be able to provide it for the purpose of the assignment. For number 8, it goes into the type of network devices that will be used in the wide area network. You would see a router, and a router can also be a gateway. There could also be a gateway. And for when we see layer 3 or layer 4 switch, this pertains to the OSI layer. From layer 3 to the higher layer, this is when layer 3 is for routing. And layer 4, that would also, we would use that for voice over IP and some of the other areas in our network. So if you have a switch that's capable of routing, that would be a layer 3 or higher switch. So it has additional capability instead of just switching. Most unmanaged switch in the lower end switch, you would see that it's in the layer 2. And similar to the earlier question, an example of a peer-to-peer network, we would see a home network or internet cafe network. It's very much on the small scale and it does lack security. So here you can see that I put down the answers, and as you go through you can view the notes. That's going to give you the general information and be able to add in the answers for your assignment. This concludes my first lecture for week 1. Please watch part 2 for topologies.